Good morning students, this is Joy Varghese from Uncovering Chemistry. Now today in video 9 we are going to discuss what we say about percentage composition. Now why percentage composition we need to study first of all. Many times when we say that is suppose a sample is given to you. So first thing for that sample comes in your mind that what is the formula of the sample. Second thing is the given pure sample is actually pure or there is some adulteration is there. So for that to find out that the given percentage is same or not, what we do is we find out the percentage. Now for finding the percentage composition, suppose we take an example of water. But before taking example of water, I will just write the formula for percentage composition. That is mass percent. When we say that is what is given there, mass percent of an element. What is the formula? Mass percent of an element is equal to mass of the element into 100 divided by mass of the element into 100 divided by molar mass of the compound. Molar mass of the compound. Here, now here we can just change little bit. Mass of the element in compound multiply by 100 as it is percentage, and molar mass what we say of the compound what we say. Okay, this is the formula. So suppose if H2O is given, what we say. So actually in water there are two atoms of hydrogen and one atom of oxygen is there. Understood? So with this total means two atoms of hydrogen and one atom of oxygen, both of these make a 100% compound. What does it make, sir? 100% compound what we say. Understood? So when we if you want to find the mass percent of an element, now here two elements are there, hydrogen and oxygen. So if I want to find the mass percent, I can write mass percent of hydrogen is equal to mass of the element in the compound. So I can write here 2 into 1 into 100. Now why I have taken 2 into 1? This is atomic mass of hydrogen and this 2 is the number of atoms. That's why I have multiplied. Here you can see 2 hydrogen atoms are there. That's why I multiplied here 2. So whole upon molar mass of the compound. So when I say molar mass, that is nothing but molar mass means what? Molar mass means molecular mass. That is water molecule. When we write, it is equal to 2 into 1 plus 16. 16. 1 into 16. That is equal to 18U. What we say. Understood? So now suppose here, if I want to write, I will write here total. That is molar mass of the compound. I write here 18. If you calculate, you will get the percentage of water, that is hydrogen, sorry, it will be 11.80. How much it is? 11.18% hydrogen is there in water molecule. Now suppose if I want to find the mass percent of oxygen. The mass percent of oxygen, only one atom is there. So 1 into 16 into 100 divided by 18 only will come, because this is the same compound what we are talking about. Understood this part? So if you calculate this, you will get this 88.79%. How much it will be? 88.79%. So both percentage we got. Hydrogen percentage is 11.18 and oxygen percentage is 88.79. Understood? So now if you want to counter check, that is the given percent or the percentage we found out is right or not, what we can do, just add this both of the things. It should be 100%. 88.79. If you do, it should be nearer to 100% what we say here. Okay. So it is 99 point what we call it as 97, that is approximately 100%. So what we found out, the percentage is right what we said. Understood? So this was one example, and this is the formula what we discuss here for finding the percentage. What is the formula? Mass percent of an element is equal to what we say it as mass of the element in compound into 100, because percentage is there, whole upon molar mass. Molar mass means what? Molecular mass what we say. Is it clear? So this part I think you understood. Now one more example we will take to understand this. Okay? See. Okay. Now the second example to understand this percentage composition is of ethanol. C2H5, that is ethanol. Ethanol. Clear? I think you must have studied in 10th standard carbonics compound chapter. Okay, organic, what we say. Organic compound. So ethanol, this also can be written as C2H, total H5 plus 1 means 6 and O. It can also be written like this. C2H, 6O means you can see in this case, that is C2, if you see here, carbon 2 atoms are there, hydrogen 6 atoms are there, and oxygen 1 atom is there. Is it clear? So this part when we say here, suppose first of all we will find the molecular mass of this. Which mass? Molar mass. What is it? Molar mass of the compound. So molar mass, when we say molar mass of C2, that is 2 into carbon, it is 12 plus 6 into 1 of hydrogen plus 1 into 16 of oxygen. If you calculate 24 plus 6 plus 16, that is 30, and this will be 46U what we say. Understood? So we got the molar mass of the compound, that is 46U. Now if I want to find the percentage, that is percentage of carbon in the given compound, that is C2O5. The percentage of carbon when we say is equal to total how many atoms are there? 2. So 2 into 12 into 100. This formula I am talking about. So this coefficient, atom, number of atom is very important when you calculate this. Is it clear? So 2 into 12 into 100 divided by the molar mass of the compound, that is 46U. So divide by 46. Same way, percentage of what we call it as hydrogen is there. Hydrogen. So hydrogen total 6 atoms are there. So what we will do? 6 into 1 into 100 divided by 46. So that percentage you can find. Same way, percentage of oxygen you find. Oxygen only 1 atom. So 1 into 16 into 100 divided by 46 we can write. Okay. So if you calculate all this percentage of carbon when we say, it is 52.14. If you calculate this, you will get 52.14. Percentage of hydrogen, if you calculate, it will be 13.13%. And percentage of oxygen when it was calculated, it was 34.73% what we say. Understood? Now the percentage what we found out, the composition is correct or not, you can check it with a counter method. This you have to do it in rough. Don't show it in a fair work. Understood? So you calculate this all. That is 52.14, 13.13 and 34.73. Right? So this will be 10, 1, again 10, 1, 4, 3, 7 plus 2, 9 plus 1, 10. And here, if you count, it is total, what we call it as 100%. Understood or not? So the percentage what we found out is the exact what we say. Means all this percentage composition of what we call it a mass percent of an element what we found out is correct. This is the best way to check that your answer is correct or not. Understood? So this is what we are talking about, percentage composition topic. 2 examples I have explained. You can write down in your fair book and see that you go through your textbook also for this. Okay. Now the next part, see. Okay. Now the next topic, that is topic 1.9.1, what we say, empirical formula for molecular formula. So we have discussed about empirical formula in formula mass topic, if you remember. Here, that is previous video we have discussed that. But here, what is empirical formula and what is the difference between empirical formula and molecular formula, that we are going to study. Okay. But in that, first of all, you take an example. of glucose you can take, or CH3COOH. I think you know this. This is an example of molecular formula of acetic acid. In organic there is IUPAC name. If you write, we can call it as ethanoic acid. Which acid? Ethanoic acid, if you remember. Understood? Now this same thing can also be written. Now this is which formula? This is molecular formula. Which formula this is? This one is molecular formula. Which formula? Molecular formula. Understood this part? Now suppose if I write for this, that is C2, I can write like this, C2H4, because 3 plus 1, C2 and O2, like this what we say. So this one what we say is the molecular formula. Now in this, if you see, there is a common in this. What is common? So 2 is common in all this. So if I divide this formula with the 2, what we say? Understood? 2. 2 means N, what we call, that I will explain in the formula what is given. So if I divide this with 2, what I will get? I will get a formula that is C, H2 and O. So this one is your empirical formula. Which formula? Empirical formula. Understood? This is your empirical formula. Understood this part, everyone? Okay? So what is the difference here? This is molecular formula, and the common part you divide the molecular formula with the common multiple, what we say. Okay? Then you can say that this is your empirical formula. Okay? And now if you find the mass of this, that is what? Suppose C means 12 plus 2 into 1 of hydrogen. This is of carbon, this is of hydrogen, plus 1 into 16 of oxygen. C also 1 into 12 what we take. So it is 12 plus 2 plus 16. So 12 plus 2, 14 plus 16, which is equal to 30U. So this is the empirical formula mass, what we say. What is this? This one is empirical formula mass. Understood? Now, and this one, for this if I find out the mass, for this one, if I find out the mass, that is what? 2 into 12, 2 into 12 plus 4 into 1, that is for hydrogen, plus 2 into 16. So if you count this, it will be what? 24 plus 4 plus 2 into 16 is 32, what we say. Understood? So if you count this, 24 plus 2, that is 28 plus 32. So it is what? 60, what we say. What is this? 60U if you count. Understood? So 60U, this is a molecular formula mass. Okay, so what is the difference between empirical formula and molecular formula? You understood here. Okay, so this is empirical formula, molecular formula. Now the relation between empirical formula and that molecular formula formula we will see. Just a minute. Okay. Now you can see here the relationship between empirical and molecular formula, what we call. So what is the relationship? That is molecular formula is equal to N into empirical formula. This is the formula what we call. Now what is N? The N is, how to find out N? That is molar mass divided by empirical formula mass. Now I gave an example if you remember. What was that example? That is of CH3COOH. So what it was? C2H4 and O2 was there. That is CH3COOH. Here this was your molecular formula. Now for this, if I want to write the empirical formula, what I have done? I have divided it with 2. If you remember, this one was divided with 2. So you got which formula? Empirical formula. That is what? CH2 and O. Understood this part? So this 2, what we call, is the N what we are talking about. Clear? So whichever will be the common multiple through which we will divide a molecular formula is the value of N what we call. Okay, so this part is clear what we say here. That is, this is the relation. You can write down this in your fair book. Now in your textbook, one example is there. Example, that is problem 1.2. That is, the question is, a compound contain 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molar mass is 90, means molar mass is given. Okay, what are its empirical and molecular formula? Problem 1.2. So that I am going to discuss and explain through what we call it as a tabular method. And this method, this question can be asked for 4 marks. How many marks? 4 marks. So that tabular method I am going to discuss the next. Okay, this part you can write down in your fair book what is given, this formula and all, because in that example also I am going to discuss how to do it. Okay, next, see. Okay, now you can see here, that is what I am talking about, problem 1.2 in your textbook. Now in that 3 elements are there, that is carbon, hydrogen and oxygen percentage are given. So first column is of element, second column percentage of element. So in that carbon it is given 24.27%, right? Hydrogen it is given 4.07% and oxygen it is given 71.65%, what we say. Understood now? This part I think it is clear. Now in this all percentage were given in question. Clear? Question it was given. Second thing given in question was molar mass, I think. The second thing was given, molar mass was given. Molar mass is equal to, it was given in your question as 98.96 gram, like this it was given. Okay, so these are the data what were given in your question. Now atomic mass of carbon we know it is 12, of hydrogen it is 1, hydrogen 1, okay, and oxygen atomic mass is 16, what we say. Okay, so now what we will do here, I think it is, sorry, here it is chlorine, Cl. Cl is this, so Cl it is 35.5. So, sorry for this, here oxygen not, chlorine is there, and chlorine atomic mass is 35.5. Now, the next column if you see, relative number of moles. Now, how to calculate relative number of moles? What you will do, you will take this percentage and divide with atomic mass. Means what? Percentage divided by atomic mass is the formula for finding relative number of moles. So, it is equal to, you can write down 24.27 divided by 12. Okay, then here it will be 4.07 divided by 1. Here it will be 71.65 divided by 35.5. So we will see how much is the what is the number, that is number of moles what we are getting. Okay, so percentage divided by atomic mass will give you the relative number of moles. So by calculation this one is 2.02, this one is 4.07 because divided by 1, and this 71.65 divided by it will be 2.02. So now here there is an important part to remember in this. What is that? Now which one is the least number of mole we got? That is 2.02 is the least number of mole. Okay, so now next topic is simplest molar ratio. When we say, in that what we have to do, whatever ratio you got, 2.02 for the first, that is for carbon, you divide it with the least one. Here also it is same only if you see, the least one, either this or any of this you can take, but least one, smallest value what we say. So I will divide this with 2.02. Now this value is there, 4.07, divide with 2.02. Again this 2.02, divide by again 2.02. Means the least value we have divided this ratio what we call. Okay. So now what you get here? You will get here 1, here it will be 2, and here also it will be 1 what we say. Understood? So now if you see the simplest whole number, there is no fraction or anything, it is a whole number. So simplest whole number for this is 1, for this it is 2, and for this it is 1. Clear? So what does this represent? This number, that is simplest whole number, molar ratio represent the number of carbon, hydrogen and chlorine. What is the word? Carbon, hydrogen and chlorine. Now if you substitute this number next to the formula, you get the empirical formula. That is, we will see in the next part, or I think you can see here at the bottom. Okay, so here if you see in this part, what is there? Empirical formula. Therefore you can write, therefore empirical formula of the compound of the compound is equal to carbon. This you can see here, it is carbon 1, so I will write here C1, no need to write 1. Hydrogen, it is 2, so I will write here H2, and here chlorine you can see, so I will write here Cl like this. Or, so this we got the empirical formula by finding out with this method. This tabular method is easy, and this question can be asked for 4 marks. How many marks? 4 marks question it is. Understood? So now the next calculation, that is empirical formula we got. Now we will find out the molecular formula. Okay? Before that I will rub this part. Just a minute. Okay. Now you can see here, from that calculation we got the empirical formula of the compound. Okay? Now after this we will find empirical formula mass. You know why? Because formula of N, if you remember. Understood? So for that, first of all, no problem, we will write N is equal to molar mass. Molar mass was the formula, if you remember, upon empirical formula mass. Formula mass. Clear? And molecular formula is equal to N into empirical formula. Understood? So for finding molecular formula we need to find N, and N formula is what? Molar mass upon empirical formula mass. So first of all we will find this empirical formula mass. So therefore you can write empirical formula mass. Empirical formula mass is equal to this, what is our empirical formula? C2HCl, that is 1 into 12 plus 2 into 1 plus 1 into 35.5, what we say. Understood? 35.5, that is for chlorine. So if you calculate it, you will get the empirical formula mass, suppose 49.5 you get. How much you will get? 49.5 empirical formula mass, right? Now this empirical formula mass I will keep here to find the value of N. So what we know, N is equal to what? Molar mass. Okay? Molar mass upon empirical formula mass. EF mass I have written the short form, but molar mass was given in the question. How much it is? 98.96. So which is equal to 98.96 divided by 49.5. Understood? 49.5. So if you calculate it, it will be equal to 2. That is, therefore N is equal to 2. What you got? N is equal to 2. Understood? Now this value will substitute here. Okay, so molecular formula is equal to N, means what? 2 into empirical formula, that is C2HCl. So this 2 will multiply with the atom. So nothing is there, say 1 and here 1 and here 2. So 2 into 1, that is C2, 2 2s are 4, that is, and Cl2. So this is your molecular formula. Understood this part? So first of all, from the percentage we found out empirical formula, and from empirical formula we found out molecular formula. So this was only possible because of the relationship what we have seen. Okay, so like this we come to an end of empirical formula and molecular formula numericals. Okay, next time we will be discussing with the next topics. Clear? Now just a minute. Okay, now there is one another example based on this empirical formula, what we say. Now this is little bit different but similar to what we have discussed for C, H and Cl. Understood or not? So this we are going to discuss next. Now in your book, if you see in textual exercise, I am talking about textual exercise 1.3, question is there 1.3. Okay, now in that oxides of iron, that is, in that iron percentage is given, Fe, and also oxygen percentage is given. From that you have to calculate empirical formula. What you have to calculate? Empirical formula you have to find out. Understood? So now first of all, the elements what we say is iron and oxygen, what we say. Symbol Fe and O, what we call it as. Okay, then percentage are given. Iron it is given 69.9% and oxygen 30.1% is given. Atomic mass of Fe, when we say it is 55.85. 55.85, and that of oxygen is 16. Okay. Now, when we say here number of moles of elements, if you remember, percentage divided by atomic mass, that is 69.9 divided by 55.85. Same way here 30.1 divided by 16. So, what we will get? 69.9 divided by 55.85, it will be 1.25, and this will be 1.88, like this it is. Okay, you can calculate and see, it will be like this. Now, suppose here if you see which is the least value, so obviously this is the least value. So if you want to find the simplest molar ratio, if you want to calculate the simplest molar ratio, how to calculate? This 1.25, this I divide with the simplest number, least number, what we say. Same way 1.88 divided by 1.25, right? So here you will get 1. But when you see the next part here, there you will get the value will be 1.5. Right? Now 1.5 value we got. We want a simplest whole number molar ratio on this side. So I cannot use this 1.5 as a whole number. So what I will do? I will multiply it with 2. Understood? With the least possible number. So I multiply it with 2, that is 2 is the least number what I have multiplied. So what I will get? 1.5 into 2, the simplest whole number will be equal to 3 what I get. Same way here, what I multiply here, I must multiply at this position also. So this one also will be multiplied by 2. So you will get here equal to 2. Understood? So this is little bit different what you have studied. So if it is not a whole number what you are going to get, you have to multiply with the suitable multiple what we call. Understood this part? Okay. So now further if you find, so therefore we can write empirical formula of the compound or what we call it as iron oxide, what was written in your question. So empirical formula of the compound, this shows the number of Fe and this shows the number of oxygen. So Fe 2 and O3, ferric oxide what we said earlier. So here this part understood? Fe2O3, this is the iron oxide and this is its empirical formula. Is it clear? So this one also you can write down in your fair book. Is it clear? So two numericals we have seen based on this empirical formula and molecular formula. Okay. So question can be asked only till empirical formula, or it can also be asked to find from empirical formula molar mass will be given. You can find molecular formula also. Okay. So this was the part regarding empirical formula and molecular formula. In the next video, we will be discussing about the stoichiometric coefficients, what we say. Okay. So that is the next topic in your book, textbook, what we say. Okay. Till then, thank you. So whatever we have studied till now, you can try by yourself from textual exercise also, assignment also I will be sending to you. Okay. So like that you can do it in your fair book, what we say. Okay. This chapter till where we have completed, that will be there in your what we call it as exam. Okay, so we'll stop here. Thank you very much.